Welcome to the course of the differential equation. In this course, we discuss in module 1 introduction to differential equation. As we all know, we have a function y is equal to f of x, where x is the independent variable and y is the dependent variable. In this function, we know the derivative that we learned in our intermediate standards, that is the first order derivative dy by dx is there, where y is equal to f of x is the function. Then we can find out dy by dx as a first order derivative, or simply we can write y dash or y1. Okay. And second order derivative, we have d square y by dx square is there, or y double dash, or sometimes we write it as y2. Okay. So, similarly we can have higher order derivative, that is d cube y by dx cube, or y triple dash, or y3 plus etc. We may have the d raised to n y divided by dx raised to n is the nth order derivative, Okay, these are the different order derivatives of a function with one independent variable and one dependent variable. Okay, we can evaluate the higher order derivatives of a function. Simply, if y is equal to x square is there, say if y is equal to x square, then we can say that dy by dx is the first order derivatives there, that is equal to 2x is there. Okay. And also we can find out the second order derivative d square y by dx square, that is we differentiate dy by dx again with respect to x. Okay. So, we will have the value is equal to 2. Now, then we can calculate d cube y by dx cube. While evaluating d cube y by dx cube, we differentiate d square y by dx square again with respect to x. But here d square y by dx square is a constant, as because it is a constant whose derivative is equal to 0. Now, all other higher derivative, that is d raised to 4 by dx raised to 4, we differentiate d cube y by dx cube with respect to x, that is since d cube y by dx cube is equal to 0, that is why d raised to 4 by dx raised to 4 is equal to 0 again. So, here onwards all higher derivative will be 0. So, like that we can find out the higher order derivatives of any function with one dependent variable and one independent variable. So, while evaluating these derivatives, our focus on the differential equation. These are the different order derivative that we will use in our differential equation. See, the actually a differential equation is an equation which involves the derivatives. A differential equation is an equation which involves or which consists derivatives. The derivative may be any order derivative, maybe first order or second order or any other higher order derivatives. So, is just an equation which involve any kind of derivative. See, that is for example, we can say that this is the y double dash plus y is equal to 0 is a differential equation. Here we have y dash is here, this y dash is the first order derivative, either y dash, or we can say that this is the dy by dx. Okay. So, this is an equation which involves the first order derivative. So, this is a differential equation. Like that we can have any other order derivatives we can found. This is for the next example. Example 2, we can say this is the example 2. In example 2, we write this is the d square y by dx square, d square y by dx square plus x into dy by dx whole square plus y is equal to 0. See, this is also a differential equation. See, in this differential equation we have derivatives. There is a first order derivative dy by dx is there, as well as the second order derivative d square y by dx square is there. The first order derivative whose power is 2 and the second order derivative whose power is 1, and also the x is there and y is there. So, simply this is also a differential equation, because which consists the derivative dy by dx and d square y by dx square. So, that we can say that this is also a differential equation. See, in this differential equation we discussed here the function as y is equal to f of x is a single variable function, is a single variable function, is a single variable function. That means the function consists only the single variable, one variable. Function consists only one variable, that is one independent variable. Okay, as because this is a single variable function, we can say that while differentiating this function we can easily differentiate with ordinary derivative. So, that see here we used the function here we used dqy by dx cube and d raised to 4 by dx raised to 4, all are the ordinary derivatives, because there we used a single variable function with one independent variable. So, here see this dy dash is dy by dx. So, this is a function whose y dash is a derivative of a single variable function. So, this is ordinary derivative, dy by dx is a ordinary derivative. As because that is a ordinary derivative, this differential equation is the differential equation which consists only the ordinary derivative. Therefore, we can say that instead of d, I would like to say this as a ODE, that is ordinary differential equation, that is ordinary differential equation. See here we have d square y by dx square, this is the ordinary second order derivative, this is the ordinary first order derivative. This is also a ODE, ordinary differential equation, because which is a derivative of a single variable function. See, dear students, while discussing this, if I would like to write this is equal to z is equal to f of x y. So, this is two variable function, because this is in two variable function. C is the x and y are the independent variable. Okay, two variable function, that is a multivariable function, and this z is a dependent variable. So, here while evaluating derivatives, as because the function consists two independent variable, we prefer the partial derivative, that is the function dou z divided by dou x, we can have the first order derivative. We partially differentiate z with respect to x, and similarly we can have dou z divided by dou y, that is we partially differentiate z with respect to y. So, similarly we can have the second order derivative dou square z divided by dou x square. Also we can have dou square z divided by dou y square, and similarly we can have dou square z divided by dou x dou y, or similarly we can have dou square z divided by dou y dou x. Okay. These are all the derivative, but these all derivatives are called the partial derivative. These all derivatives are the partial derivatives. See, these are all the partial derivative. The partial derivative exists because of the function is two variable or multivariable function. So, in case of the multivariable function, we can have the differential equation which involves the partial derivative. Such differential equations are called partial differential equation. See, we can have dou z divided by dou x and dou z divided by dou y is equal to 0. This is one of the example of the partial differential equation. So, the differential equation which involves only partial derivative. So, this is what is called PDE, the partial differential equation. So, in this another example we can have, in example 2 we can have dou square z divided by dou x square plus dou square z divided by dou y square is equal to 0. This is also a differential equation which consists the second order partial derivative. As because this is a equation which consists the second order partial derivative, which does not consist the ordinary derivative, the equation consists only the partial derivative. That is why we call it as the PDE. This is also a partial differential equation. Okay. So, in our course, our focus is only on the ordinary differential equation. We focus only the ordinary derivative, the ODE. So, this ODE also we can categorize as different order derivatives are there and different degree differential equations are there. So, since there are many higher order derivatives are there, we can define what is the order of a differential equation, what about the degree of a differential equation. See, dear students, so we discussed the order of a differential equation, partial differential equation and ordinary differential equation. Now, our discussion on the order and degree of the differential equation. Okay. Order and degree of a differential equation. Order and degree of differential equation. See, what is the order of a differential equation? As we discussed, a differential equation may contain many ordered derivative. There are first order derivative dy by dx is there, and the second order derivative d square y by dx is d square y by dx square is there. Similarly, etc. may be the nth order derivative d square d raised to n y divided by dx raised to n is there. So, any order derivatives may consist in this differential equation. So, while seeing the differential equation, see the differential equation dy by dx plus x into d square y by dx square is equal to 0. See, this is the differential equation. In this differential equation, while evaluating, we can have two derivatives are there. The first one is the derivative, that is the first order derivative dy by dx is there. Similarly, there is a second order derivative d square y by dx square is there. See, while evaluating, while finding, while searching the derivatives, which is the highest order derivatives in that differential equation? The highest order derivative in that differential equation is the second order derivative. This d square y by dx square is the highest order derivative involved in that differential equation. That is why we can say that this differential equation is second order differential equation, ordinary differential equation. See, now we check which is the highest degree, highest power of the highest order derivative. So, highest power of there are two order derivatives are there. First one is the first order derivative dy by dx, and the second one is the second order derivative d square y by dx square is there. We know we understood it is that second order derivative is the highest order derivative involved is. So, we will check the highest power of the second order derivative, the highest order derivative. The highest power of the second order derivative is actually, the highest power is here, it is the 1. This is the first degree equation. So that we can say that this is the second order first degree ODE. Second order first degree differential equation ആണെന്ന് second order first degree ODE. Okay, fine. Now see, what is the order? The order of the derivative, order of a differential equation, order of a differential equation is the highest order derivative, is the highest order derivative involved in that differential equation. So while evaluating the order of the differential equation, we will find which is the highest order derivative involved that differential equation. And the degree of a differential equation is, degree of differential equation is the highest power of the highest power of the highest order derivative. Highest order is the highest power of the highest order derivative. The degree of differential equation is the highest power of the highest order derivative. See, here we have dy by dx plus x into d square y by dx square is equal to 0. In this differential equation, the highest order derivative is the second order. That is why this is the second order ordinary differential equation. And while evaluating here, the highest order derivative is the d square y by dx square is there. The highest power of the highest order derivative, that is the here the power of the d square y by dx square, because the equation consists only one term of the d square y by dx square. That is why the highest power of the d square y by dx square is the first one. So this is the first degree differential equation. Okay, now we can move to another example. Find order and degree of differential equation dy by dx plus x into d cube y by dx cube plus x square into d square y by dx square is equal to 0. Say, while evaluating this differential equation, say from the equation itself we understood it is that there are three order derivatives are there. See, the first order derivative is there, this dy by dx is the first order derivative, and dqy by dx cube is the third order derivative, and d square y by dx square is the second order derivative. See, the equation have three order derivatives are there. The highest order derivative is the third order derivative. That is why order of differential equation is equal to 3. And what about degree of the differential equation? Degree is the highest power of the highest order derivative. The highest order derivative is d cube y by dx cube. Only one term of d cube y by dx cube is there in equation. That is why we just consider that term only. So whose power is equal to 1? Therefore, degree is equal to 1. See, this is the third order first degree ordinary differential equation, because ordinary derivatives are only involving it. See, we can move to next question. Next question. See, in this question we have d square y by dx square minus 1 minus dy by dx whole square whole square whole raised to 3 by 2 is equal to 0. So, you have differential equation is here, that is d square y by dx square minus of 1 minus dy by dx whole square whole raised to 3 by 2, which is equal to 0. See, here we have the rational powers are there, have to remove the rational powers first, we have to make the differential equation with only the integer powers. So, for that we just take this is to here, we just take this is to the right hand side. So, that we will have differential equation as d square y by dx square, the differential equation as d square y by dx square equal to 1 minus dy by dx 1 minus dy by dx whole square whole raised to 3 by 2. Okay. So, we have to remove this rational power. So, you have to the rational power, the denominator power is 2. So, the power is 3 by 2, since because power is 3 by 2 we will square both sides. So, squaring both sides, squaring both sides. So, we will have d square y by dx square whole square is equal to, while squaring this is 1 by 2 will go, therefore, the term will consist only 1 minus dy by dx whole square and whole cube is there. Okay. Fine. Now, this is okay. Equation is unfair because all the rational powers are removed, only the integer powers are there, that is why we are okay, we are happy. See, my dear students, while checking this differential equation, we understood it is that there are two order derivatives there. This is the dy by dx, dy by dx is the first order derivative. So, we have the first order derivative and as well as we have here is the, this is the second order derivative. Okay, the differential equation consists only the two order derivative, first and second order derivative. So, we are okay, fine. The highest order derivative involved in that differential equation is the d square y by dx square. That is why okay, fine, we can say that the highest order derivative is d square y by dx square. Therefore, we can say that the order of this differential equation is 2. Now, while seeing checking this differential equation, here we have 1 minus dy by dx whole square whole cube. So, while expanding this, when we expand this, we understood it is that we have dy by dx whose power will be, maximum power will be 6. But even though here we have the highest order derivative, the highest order derivative is d square y by dx square. As because highest order derivative is d square y by dx square whose maximum power is equal to 2. Therefore, degree is equal to, we can say that, therefore, degree is equal to 2. So, we have a dy by dx may have the maximum power 6, even though the degree is equal to 2, because the highest power of the highest order derivative is equal to 2. Okay, fine. This is the about the order and degree of a differential equation. As we discussed before, we have the partial derivative may exist there. We have while moving to next example, the example 3, see just example 3. In example 3, we can have the find order and the order and find order and degree of the differential equation dou square y by dou square z by dou x square plus dou square z by dou y square is equal to 0. Say while seeing the differential equation, we understood it is that this is the partial differential equation because the differential equation consists only the partial derivatives. As because it consists only the partial derivative, we will check the order of a partial derivative, which involves dou square y by dou x square as well as dou square y by dou y square. Only the second order derivatives are involved there. Therefore, the order of the derivative, highest order derivative involved is there, second order. Therefore, the order is equal to 2. Order of the differential equation is equal to 2, and as well as we can, while checking powers of the differential equation. While evaluating the powers of differential equation, dou square y by dou x square whose maximum power is equal to 1, and dou square y by dou x square dou y square whose maximum power is equal to 1. So that we can say that it is a second order derivative and first degree equation. Second order and first degree partial differential equation. This is the second order first degree partial differential equation. So, while evaluating order and degree, we have many choices may exist there. See, I would like to write one more example. See, in this example, we can say that the order evaluate order and degree of differential equation. Evaluate order and degree of differential equation. dqy by dx cube is equal minus 1 minus d square y by dx square whole raised to 3 by 5 is equal to 0. Say, while seeing this differential equation, we understood it is that the differential equation consists on a rational power. As because there is a rational power, we have to make all powers to be integer power first. So, we just took, as we done before, we just took this term to RHS side. So, we will have d square y by dx square is equal to, sorry, dqy by d cube y by dx cube equal to 1 minus d square y by dx square whole raised to 3 by 5. Okay. Now, we have to remove 1 by 5 from here. So, we have to power with both side power with 5. Powering both sides with 5. Powering both sides with 5. See, while powering both sides with 5, we have, this is the d cube y by dx cube whole raised to 5 is equal to 1 minus dy by d square y by dx square whole raised to 3. Here we have 3 by 5 is here, while powering with 5, this 5 will cancel, and therefore, the power is equal to 3. So, from here it is that while evaluating, while checking this differential equation, we understood it is that the highest order derivative is the third order derivative, whose maximum power is 5. So, we can say about this differential equation, this is the third order, fifth degree 5, whose degree is 5, fifth degree ordinary differential equation. Therefore, the order is equal to 3 and degree is equal to 5. So, these are the basics of the differential equation. Actually, in this course, we will discuss the solution of the differential equation, that we will discuss in our next modules. Just I am giving some assignments to evaluate order and degree of differential equation. find order and degree of following differential equations. First one, dou square z by dou x square plus dou square z divided by dou y square, dou square plus dou y by dou x is equal to 0 is a partial differential equation which involves the dy by dx, d square y by dx square, sorry, d square z by dx square, and d square z, sorry, dou square z by dou x, dou y square, and dou square z by dou x square is there. The second equation, second question, the second one, dy by dx minus 1 plus d square y by dx square whole square whole raised to 3 by 2 is equal to 0. Okay. And the third equation is d square y by dx square plus x into dy by dx whole square plus y is equal to 0. So, just evaluate order and degree of the differential equation of this question. You can find many differential equations from the literature. You can use and familiar about the differential equation, that will be helpful for your further sessions. In the next session, we will discuss about the solution of the differential equation. Thank you for watching these videos. Continue your watching. Thank you.